Morning, students. Hello.
Morning, sir.
Good morning.
Could you receive my voice?
Yes, sir.
Very good.
Yes, sir. Audible, sir.
Very good. See, today our topic is center of gravity. Center of gravity. Before discussion, the center of gravity. What do you mean by center of mass? Anybody? Center of mass. Boys and girls. Say anybody center of mass?
Body is
Yeah.
the point where the entire mass is appears.
Yeah. Correct. Next. Before discussion, center of gravity, before discussion, but know well the center of mass. If you can't to identify the center of mass, if the center of gravity is not so, also can't do. Explain this. What do you mean by center of mass? Center of mass is nothing but center of mass of a body or a system. Center of mass of a body or most of the system. Center of body of mass or system of body as a point at which the entire mass at a point which the entire mass of the body or entire mass of the system of body
Is concentrated.
very good, supposed to be concentrated very good. Concentrated. This is very important. In particular point, the overall entire mass concentrated in particular point. That point is called the center of mass. See, the center of mass of body or center of mass of system of body, which the entire mass of the body or system of body supposed to be concentrated. If all the external forces acting, if all the external forces acting on the body or system of the body were to be applied at the center of mass, were to the applied at the center of mass, the status is rest or uniform motion shall remain unaffected. It's very important. Shall remain unaffected. This is a basic information of center of mass. I give you one more explanation for definition of center of mass. The center of mass of body or system of body as a point at which the entire mass of the body or system of the body concentrated, supposed to be concentrated. If all the external forces acting on the body or system of the body want to be applied at the center of the mass, the state of rest or the state of uniform motion of the body shall remain unaffected. This is a basic information of center of mass. Okay. Say yes or no?
Yes, sir.
Great. Now we are discussing about you know well the center of mass and the center of mass of the rectangular, square, and sphere, semi-sphere. Am I right?
Yes, sir.
Very good. I give you some formula also. Where the uniform hollow sphere, the center of mass placed. The uniform hollow sphere. The position of center of mass is where it is located.
R.
R means what do you mean? Uniform hollow sphere. The position of the center of the mass placed at the center of the sphere. Center of the sphere. I give you points. First of all, you are explaining this center of gravity. What do you mean by center of gravity? Each rigid body, just consider one rigid body. Consider one rigid body. I want to take this rigid body. Each rigid body is made up of several point masses. Am I right? You know well. Several point masses. N number of point masses. You know well. Am I right? Such point masses experience gravitational force due to the acceleration due to gravity. Each point mass. I want to take the point mass is possible. I. If I is equal to 1, 2, 3 up to n. Okay. The gravitational force. You know well. The gravitational force is now just forces. Weight up. Says or no?
Yes, sir.
Yes, sir.
Very good. See, each point masses experiences gravitational force towards the center of the earth because of the acceleration due to gravity. For example, the center of the mass, just I want to take one is the gravitational force, this is W1, and one to another one, this is W2. W2 means whose is? Whose is
Weight of
W?
another mass.
Weight of another one.
Am I right?
Yes,
Yes, sir.
Just another one point mass. I want to point mass W3. Another one point mass. This is W4.
W4.
Overall point masses are concentrated in particular
WN.
point. And overall is equal to WN. So
WN.
overall, listen all of you. The gravitational force towards the center of the earth as the size of the the size of the earth is very large compared to any practical rigid body. The mass of the earth or the size of the earth is very large compared to any practical rigid body. So we come to across in the as usual your daily life, these forces appear to be acting parallelly downward direction. This is nothing but this is a gravitational force. The overall gravitational force are concentrated in the center of this point. This is equal to W. The resultant of these parallel forces W1, W2, W3, W4 up to Wn. The resultant of these parallel forces always acts to be a point. The resultant of these parallel force, whose is parallel force here? Parallel force means whose is? Gravitational.
W1, W2,
Gravitational.
W3, W4.
These parallel forces always acts to be a point. Acts to be a point. This point is called as center of gravity. This point is called as center of
Gravity.
Very good. Which means the center of gravity with respect to Earth. With respect to Earth. I want to explain the center of gravity definition, which is equal to the center of gravity. See this, the center of gravity. The center of gravity of a body. The center of gravity of a body is the point. Is the point. Which point? Is the point at which the entire is the point at which is the point at which the entire weight of the body, entire weight of the body. See, what is the difference between center of mass and center of gravity? If consider the point mass is m, am I right?
Yes,
Overall point masses are concentrated at a point. The point is called as a center of mass. Each and every point mass is affected by acceleration due to gravity. Am I right?
yes, sir.
These acceleration due to gravity is overall produced to the weight of the point masses. These is overall weight of the point masses are, these gravitational forces. The center of gravity at a body is the point at which the entire weight of the body acts irrespective of the position and the orientation of the body. The entire weight of the body at a point, this is called as center of gravity. It acts, depends upon, it is a very, very important. It acts as irrespective of the position. Listen to me, this is a very important word. Irrespective of the position and orientation. This is a very important one. The center of gravity of body is the point at which the entire weight of the body concentrated in a particular point. That is the point. Is called as nothing but the center of gravity. Center of gravity. Another word is a very important one. This is act as irrespective of the position and orientation of the body. The center of gravity and center of mass of rigid body coincident. It's a very important another word. Is the difference between the center of mass and center of gravity. The center of the gravity and center of the gravity and center of the mass. Just CG means who's it? Who's it? CG.
Center
of gravity.
Gravity.
CM means
Center of mass.
very good. The center of gravity and center of mass of rigid body is very important. Rigid body coincident when the gravitational field is uniform. This is coincident. This is coincident when we are recording the condition.
Gravitational field is uniform.
Very good. Gravitational field is uniform. This gravitational field is uniform. This is a very important condition for 1 mark. This is center of gravity and the center of mass of rigid body coincide when the gravitational field is uniform across the body. Next one is, I want to calculate the center of gravity. Center of gravity, just give you some shortcut word. If consider 3 diagrams, I will draw the 3 diagrams. See this. You know well, this is a point mass, gravitational force W1, another one point mass, gravitational force W2, and overall this is W3 and W4, and there's also W5 point masses. Am I right? Say something.
Sir.
Very good. Another one is, this point is center of gravity means, just consider center of gravity means the overall weight is acts in this point. Am I right?
Yes, sir.
Yes, sir.
Just I want to take this. These diagrams should be balanced. This diagram must be balanced. At the point, this is center of gravity G. Should action reaction force. Am I right?
Yes, sir.
This
So,
diagram should be balanced when the conditions of third diagram. This is third diagram. This is second diagram. This is first diagram. Am I right?
yes, sir.
Yes, sir.
See the first diagram. I want to explain the center of gravity of body point, where the entire weight of the body, gravitational force, the gravitational force on the body. Who's this? Gravitational force of the body. Who's this? Gravitational force on the body. Who is this?
Center of gravity.
Weight. Am I right?
Yes, sir.
The center of gravity of your body is a point where the entire weight of the body, is nothing but this is the gravitational force on the body acts. The gravitational torque on the body about this point is always zero when the balance. And the balance condition means this third diagram. That's why I want to take the third diagram. Conditions apply. The gravitational torque on the body about this point is always zero. About this point is when the center of gravity. This is one more question. Just take notes. In center of gravity, at the point, who is zero? Who is zero?
Dot.
Very good. Gravitational torque. Already explained this gravitational torque. Just I want to take this. Just gravitational torque on the body. Gravitational torque on the body. Above this point. This point means who is this? Center of gravity.
Yes, sir.
About this point. This point means who is this? Center of gravity is always zero. Always zero. So one more question. Just consider the first diagram. How does the first diagram? The particle of your body situated at a different position. Am I right? See the first diagram. Overall weight W is equal to who's this? Sum of the all weight of the point masses are.
Yes, sir. R. Point masses.
Weight of the
Point masses.
point masses. Very good. See this. W is the resultant weight of the body acting on the center of gravity of the body. Just I want to take who is W is the center of the resultant weight of the body. W is the resultant weight of the body, which is equal to sum of the all point weight masses. Weight of the point masses acting on the center of the gravity of the body. Just I want to take the center of the gravity of the body is balance point. Where the balance point? I mean third diagram.
Yes, sir.
Very good. It implies the gravitational torque on the body about CG is zero, which means the torque which is equal to zero at the center of the gravity of the body. Am I right?
Yes, sir.
I want to determine the gravity of the irregular shaped body. Just I want to take one cardboard. See, just consider one point mass M1, another one point mass. This is M2. The gravitational weight, gravitational force M1G and M2G. M1G and M2G.
G.
Very good. If assume that the center of gravity is here, just the tip of the pencil or needle is balanced at the point. Okay.
Yes, sir.
Very good. The overall weight, which is equal to W is equal to entire mass into gravity.
Yes, sir.
Yes,
M.
sir.
This is calcium.
Entire mass of a point.
Very
Point
good.
of-
Entire mass of this board,
Needle or
which is equal to same time the reaction force should have in opposite direction.
Yes, sir.
This is equal to M into G. Am I right?
Yes, sir.
Very good. Who is this R?
Normal.
Normal force.
Normal force or reaction force? Now we are indicating the
Reactional force.
reaction force. The point of balance is the center of gravity of the cardboard. The tip of the pencil at the point G provide a reaction force R. Am I right? The R direction is upward direction up.
Yes, sir.
The total weight W is equal to calcium into G of the cardboard.
Yes, sir.
Cardboard is in a translation equilibrium conditions. That's why I want R is equal to M into G. Am I right?
Yes, sir.
Very good. If consider only point is Particle of mass, just I want to take any one of the point of the particle of mass mi. Mi means just any one of the point. Am I right?
Yes, sir.
Is placed the position vector is equal to ri vector. Says or no?
Yes, sir.
Very good. What is the force of gravitational force? Force of gravity.
mg.
MIG. Yeah.
G.
Yes,
Yes, sir.
sir.
Very good. Whose is R?
Reaction
Reaction
force.
force. Reaction
No,
force.
caps R is a reaction force. I want to take the small r.
Distance between
Distance between mi and m.
center of
The
object.
position vector R.
Yes, sir.
Yes,
Very
sir.
good. The point is placed in the point mi point mass. I is the particle. Just consider I value which is equal to 1, 2, 3 up to n. I want to consider on the point mass. The point mass is mi. Point mass is mi. The position vector of the point mass which is equal to ri. What is the torque? Then the torque above the center of gravity is. What is this torque? What is the formula? Torque tau is equal to tau I vector which is equal to
F4 sin theta.
perpendicular distance into force of.
Yes, sir.
Yes, sir.
Am I right? So the position vector into force. Just I want to take this MIG vector. Am I right?
Yes, sir.
So just I want to take the center of gravity of cathode is so located at the torque is due to the force of gravity. Overall particle, the force of gravity which is equal to, I mean, particles is overall center of gravity. I mean, the torque is balanced by the all point masses. That's why is equal to 0.
Yes, sir.
So the tau vector which is equal to, just I want to take the summation of overall point masses. I is equal to up to n. I is equal to up to 1, 2, 3, 4 up to n. Am I right?
Yes, sir.
Yes,
Is
sir.
equal to tau I vector. Tau I vector which is equal to summation of I tends to 1 and I tends
Equals then
N
or I vector
I vector in
mi vector.
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 am I right?
Yes,
Yes,
sir.
sir.
Which is
Yes, sir.
equal to 0.
Equal to 0.
What is the condition? At center of gravity, torque should be balanced.
Yes, sir.
All point masses produces some gravitational torque at the center of gravity. These gravitational torque must be
0.
must be 0. Very good. So just I want to take this gravitational vector. Overall formula which is equal to, see this, the G value is constant. G value is same for all point masses. Just I want to take the equation summation of I tends to 1 and I tends to n. I R I vector which is equal to 0. It is equal to 0. This is the condition. This is the
Condition.
and when the center of mass of body lies at the origin. Lies at the origin. Positive, I mean this position vector, R vector are taken with respect to center of gravity. The center of gravity of body coincides with the center of mass of the body. Center of gravity coincides with the center of.
Mass of the body.
When we are required this condition. Already I explained this. Center of gravity and the center of mass coincident.
When gravitational force is uniform.
Universe.
Gravitational field is
Field is uniform.
very good. The gravitational field is uniform. This is a very, very, very important condition. This is your textbook. Just take. See this. This is the basic information of center of gravity. And also we are also measured another one method in our textbook. See the diagram 5.17. Just I want to take this diagram. See this. The point is considered at this region. Listen to me. You can also determine center of gravity of uniform laminar of even and irregular shape. Even and irregular shape by pivoting its various points by trial and error. Just I want to take this. The lamina remains horizontal when the pivot at the point where the net gravitational force acts. Net gravitational force acts. You know well the W is equal to mg. Am I right? This mg is nothing but this is a total entire mass. The center of gravity. When your body is supported at the center of gravity, some of the torque acting on all point masses of the rigid body becomes zero. This is a very, very important condition. Just consider one point mass. This is a position vector. This is a gravitational force MIG. This is RI. Mass of the point mass is MI. If just I want to take when your body is supported at the center of gravity, some of the torques is a very important. Some of torques, some of the torques acting on all the point masses, all the point masses of a rigid body becomes zero. Becomes zero. This is the information. So if the balance this point, this point is a center of gravity. This point is nothing but what is center of gravity. When the sum of the torque acting on the all point masses of rigid body becomes zero, means the point is nothing but what is center of gravity. In your textbook, this is a very important. See the diagram 5.17. Moreover, the weight is compensated by the normal reaction force. You know well this is R. If the weight M1 or this is considered this is M1 point, M1 particle, this is M2. If M1 or M2, any one of this is greater or less than 1, less than M1, M1 or M2, just consider 2 point masses from left and right. If any one of these is a greater value, then nothing but the torque T1, tau1, this is tau2. If the balance torque is balanced, which means the torque is equal to zero, means the point is center of gravity. Point is nothing but this is center of gravity. And condition, moreover, the weight is compensated by the normal reaction force or balanced by the normal reaction force. Or is balanced, compensated by the normal reaction force. Is very, very important. The body is in static equilibrium. Now the condition, the body is static equilibrium. Static equilibrium. This is very important. Start to does not fall. This is a static equilibrium, and hence it remains horizontal, just to maintain an horizontal condition. And next one is a another one method is also measured in center of gravity. See this, just I want to take 3 non-uniform irregular shape of the cardboard. Just I want to take this irregular shape. Consider 3 point, this is P, and this point is Q, and this point is R. If the point P and Q and R, just a vertical line to draw this from the point P, from the point Q, and from the point R. Just this point. This is P dash. From Q, this is Q dash, and from R, this is R dash. See the points P, Q, R, the vertical lines P dash and Q dash and R dash all pass through the center of gravity, which means these points coincide with particular point. I mean, intersect this point. This point is nothing but this is center of gravity in irregular shape. The reaction force acting at the point of suspension and the gravitational force acting at the center of gravity cancel each other. It's a very, very, very important note. In this condition, reaction force acting at the point of suspension, and the gravitational force acting at the center of gravity cancel each other. This is very, very important. The gravitational force acting at the center of gravity, cancel each other. That's why it's balanced. Cancel each other, and also the torque caused by them also cancel each other. Torques caused by them means each and every point masses produce a torque. Overall, the torque is also cancel each other. This is another one important point of center of gravity. See, next one is I want to take the center of mass of some body. Well-known rigid bodies are given below. Just I give this in point. Listen to me. I want to take this square. Hello?
Yes, sir.
Yes, sir.
Yes,
sir. Yes, sir.
Yes, sir.
There is center of mass of some well-known rigid bodies. What is the main difference between center of mass and center of gravity? The main difference between center of mass and center of gravity. Okay, I explain this. Say this: the center of mass of uniform rectangular and uniform square, and the circular plate. Lies at the center. This is diagonal. Just I want to the intersection of these diagonals. This point is center of mass. Says or no? If the field is same, this point is also equal to center of gravity. Okay. Says or no?
Yes,
When we
sir.
are recording center of mass and center of gravity is coincident. Hello?
Yes, sir.
Center of mass and center of gravity coincide. Conditions of
Yes, sir.
The
condition.
gravitational field is uniform.
It is Another one notes, just take this point number 1. This is the center of mass. I give some formula. Center of mass of uniform circular ring. Center of mass of a uniform semicircular ring of a radius r. Just take note, this is a formula, radius r. Semicircle. This point is radius r. Am I right? Says or no? The center of mass of uniform semicircular, the ring of radius r. The distance, the center of mass at distance h, which is equal to 2r pi, 2r divided by pi. From its center, this point is center of mass. This point is center of mass. This height is equal to h is equal to 2r divided by pi. This is the first formula of center of mass. And second one, center of mass of uniform semicircular disk. Uniform semicircular disk. The radius is equal to r. Just I want to take this semicircular disk. This is, this disk is semicircular disk. This is also point, and this is radius of the semicircular disk. What is this? Height of the center of mass is placed the formula, which is equal to height which is equal to h is equal to 4r divided by 3 pi. 4r divided by 3 pi. And give me another one formula. Center of mass. Center of mass of a hemispherical cell. Hemispherical cell. It's another one formula. Hemispherical cell. The radius is r. Radius is r. The distance is just hemispherical cell. This is a radius of the spherical cell. The height must be required. This point is the center of mass. So the height which is equal to formula h is equal to r by 2 from center of the axis. Center of the axis. And next one, I give another one formula. Center of mass of solid hemisphere. Center of mass of a solid hemisphere of radius is r. Just consider same diagram. This is, but the hemisphere point is radius r. The center of mass is required in this point cm. The height of the formula h is equal to this height, which is equal to h, which is equal to 3r divided by 8. 3r divided by 8. This is a very important formulas for center of mass. Because first one is the center of mass of uniform semicircular ring. H is equal to 2r divided by H. And second one is, what's this? Mass of uniform semicircular ring. Sorry, semicircular disc. Second one. The second one. Third one is semispherical shell. And the fourth one is center of mass of solid sphere. Center of mass of solid sphere. Already you know well the center of mass point, center of mass formula. Anybody say center of mass?
The entire mass of a body at the point is concentrated.
Formula, I want the formula.
Summation
Torque is equal to F4 sin theta.
M1, X1, position vector, X1 and X2. The mass of the point masses of the two particles, mass M1 and M2. What is the center of mass which is equal to?
summation
M1 X1 plus M2 X2 divided by M1 plus M2R.
Yes, sir.
Yes, sir.
And next one is also velocity of center of mass. It is very important. This formula is very important. These four formulas are also very important. Another one formula give you velocity of center of mass. Velocity of center of mass, which is equal to V vector center of mass, which is equal to M1 V1 vector plus M2 V2 vector plus up to Mn Vn. Am I right? If the n point number of n point was the record means the overall vector which is equal to M1 V1 plus M2 V2 plus up to Mn Vn whole divided by M1 plus M2 plus up to M up to Mn. Okay, just I'll give one example problem. For equal masses, for equal masses, M lie at the center of a rectangle of width A and length B Where is the center of mass? Like what? Where is center of mass? See this. Four equal masses lie at the center of rectangle. This I want to take the diagram for our coordinates x and y. Consider the point. This is one. Another one is x is equal to b point. This is, and is also from a rectangle. So that's why this is this distance y is equal to a, because of four equal masses m lie at the center of rectangle of width a and length b. Just I want to length in x-axis, within y-axis. One corner at the origin. Just I want to take the corner is placed at the origin. So this point. Another one mass. This is. And I want to calculate this center of mass based off x-axis. center of mass, which is equal to, what's the formula? Summation of mi xi whole divided by overall mass, which is equal to, what's the formula? M of x1 plus x2, m1 x1 plus m x2 whole divided by m1 plus m2. So m is common because of 4 equal masses m. That's why I want to take this. The first one is 0. This point 0 plus another one is b. Another one is also b. This is another one is also b plus, and next one is 0 because of x-axis. So 2 point. One is b, another one is also b. Remaining is y is equal to a based on the origin point. That's why whole divided by total mass. What is the total mass? 4 masses required. So total mass is equal to 4 m. Just I want to take this. What is the result value? Which is equal to 0 plus 0 of m of 2b whole divided by 4m. This is m cancel. This is 2, which is equal to b divided by 2. Basis of x-axis, the center of mass required, which is equal to distance of b by 2. B divided by 2 means this point. I want to take in the y-axis also. What's the y-axis? In y-axis, y center of mass, which is equal to summation of m I. It's not this xi, this is yi whole divided by total mass, which is equal to 4 equal mass same. That's why mass should be common, which is equal to first question 0, second one is also 0 plus third one from y-axis. So plus a, another one is also plus a whole divided by total mass 4a. So it is equal to y center of mass base of y-axis, which is equal to m into 2a whole divided by 4m. So mm cancel, which is equal to 2 times a divided by. Base of y-axis center of mass record this a divided by 2. This is a by 2. Okay. Very good. Next one is, yes, very easy one. Two ball of masses 3m. Two balls of masses 3m and m. 3m and m are separated by a distance L. Separated by a distance L. Whose is 3m and m. Find the position of center of mass. Very important. Find the position of center of mass. Position of center of mass. Just I want to draw the diagram. See this. What is the mass? One is a 3m, another one is m. Just I want to take this is 3m, another one is m. Separated by a distance is L. Separated distance is L. What is the question? Find the position of center of mass. Just I want to take this. I don't know the center of mass from between the 3m and the m. Just consider one point. Just consider one point. This is center of mass. From mass is 3m. The distance is considered x. So what is this distance? The distance between 3m and m is L. Just consider the point of center of mass point. This placed at the x distance from 3m mass. So what is this remaining distance? For the center of mass point is placed at the from mass of m, which is equal to, this is L minus x. L minus x. I know well this is the center of mass, the total torque must be 0. The torque must be 0. Just I want to take this m3m into x, the formula, moment of inertia, I know well this 3m into distance x, which is equal to mass m into distance. What is this? L minus x. It's a balance at the point of center of mass. Center of the mass. What is this? I want this x value is equal to 3m into x, which is equal to ml minus mx. I mean, just I want to show, sorry, this just cancel the value. Easily cancel this. Direct answer. Cancel. Remaining 3x, which is equal to L minus x. So which is equal to L is equal to 4x, 3x plus x. So just x is equal to L divided by 4. I mean the quarter of overall length. Quarter of overall length placed at the center of the mass, which means this is L divided by 2. This is also L by 2. And next one is L by 4 means this is L by 4. This is also L by 4. The x value is equal to L by 4. From the x, whose is x, the center of mass is placed from 3 times of mass. I mean 3m mass. I got x value is equal. I mean this point is nothing but center of mass. Center of mass of this question. Very good. X is equal to L divided by 4. Hello, friends.
Sir.
Hello.
Just time up. So we will discuss about next class.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Any doubt?
Thank you, sir.
No, sir.
Very good.